In this video, we will solve ECAT past paper. The question 1 says that two pendulums begin to swing simultaneously. The first pendulum makes 9 full oscillations while the other makes 7 oscillations. The ratio of lengths of the two pendulum is, we know that T is equal to 2 pi under root L over G. From this relation, we can say that time period is equal to L1 over L2 whole under root. We know that T1 is equal to 7 while T2 is equal to 9. So this formula here becomes T1 over T2 whole square, which is equal to L1 over L2. By solving it, we get 49 by 81. Therefore, option D is the correct answer. Moving on to the next question. Question 2 says that a scooter of mass 120 kg is moving with a uniform velocity of 108 km per hour. The force required to stop the vehicle in 10 seconds is, in this formula we have 120 kg of mass. If we convert velocity into meters per hour, we will get 30 meters per hour, and Vf is 0 and time period is 10 seconds. First, we will solve for acceleration by this formula, which is A is equal to Vf minus Vi over t. Here, Vf is 0 while Vi is 30 divided by 10, we get minus 3 meter per second. To calculate the force, we will use a formula which is F is equal to ma. Here mass is 120 kg while acceleration is minus 3. So we get minus 360 Newton. Here minus represents that we need the force in opposite direction. Therefore option B is correct answer. Question 3 says that a ball of mass 0.25 kg attached to the end of a string of length 1.96 meters is rotating in a horizontal circle. The string will break if tension is more than 25 Newton. What is the maximum velocity with which the ball can be rotated? We know that the formula for centripetal force is F is equal to mv square over r. By rearranging it, we get V is equal to under root Fr over m. From the formula, we know that mass is 0.25 kg, length is 1.96 meters, and force is 25 newtons. By putting values and solving it, we will get under root 196, which is equal to 14 meters per second. Therefore, option C is the correct answer. Question 4 says that light roofs are blown off during windstorms. It is because of, here I have a house and this is the roof of the house. When there is a windstorm, the pressure outside increases while the pressure inside is less. So due to the difference in the pressure, the roof blows off. Therefore, option C is the correct answer. Question number 5 says that three blocks of masses M1, M2 and M3 are connected by massless strings as shown on the frictionless table. They are pulled with a force of 14 Newton. If M1 is 10 kg, M2 is 6 kg and M3 is 6 kg, then the tension T2 will be, we know that the tension T2 is present between M2 and M1. Therefore, we can say that T2 is equal to M2 plus M3 into A. To calculate the acceleration, we will use a formula which is F is equal to M total into A. We know that the force is 40 and mass total is equal to 22. So acceleration will be 1.82 meter per second square. Now we will solve for T2. We will get 12 into 1.82, which is approximately equal to 22 Newton. Therefore, option A is the correct answer. Question 6 says that in wave motion, the least distance between two points which are out of phase is, we studied that the points that are out of phase by 180 degrees are a half wavelength apart, which means their wavelength, which is lambda, divides by 2. So option B is the correct answer. Question 7 says that a particle performing simple harmonic motion when its displacement is 3 cm, its acceleration is 12 cm per second square, it is vibrating with period. We know that the displacement is 3 cm and its acceleration is 12 cm per square. To solve this, we will use a formula which is A is equal to minus omega square x. When we will solve for omega, we will get under root A over x. By putting values and solving it, we get 2. Now we will solve for the time period. We know that the time period is t is equal to 2 pi over omega. Here omega is 2, so 2 cancels 2, we get pi. Hence the answer is C, pi seconds. Moving on to the next question, question 8 says that if the amplitude of a wave at a distance r from a point source is A, the amplitude at a distance 2r will be. We know that amplitude has an inverse relation with distance. Therefore, if the distance is increased, the acceleration will decrease. So we have r is equal to 2r. So amplitude will be a over 2. Hence option A is the correct answer. Moving on to the next question. In a noiseless transformer, an alternating current of 2 ampere is flowing in the primary coil. The number of turns on the primary and secondary coils are 100 and 20 respectively. The value of the current in the secondary coil is. From this we can say that this is the current in primary coil, while 100 are the number of turns in primary coil and 20 are the number of turns in secondary coil. To solve this, we will use the formula which is IS over IP is equal to NP over NS. We know the value of IP, NP and NS, so we will solve for IS, and after solving it, we get 10 amperes. Hence, option B is the correct answer. Moving on to the next question. Question 10 says that satellite is launched from the Earth into orbit. What happened to the mass of the satellite and its weight? We know that a mass remains same as it is a measure of the amount of matter in an object and does not change regardless of its location. So we can say that the mass remains same. Talking about the weight, if this is the surface of the earth and rocket is moving upward, the gravitational force will obviously decrease as the weight is the force exerted by the gravity on an object. And as the satellite moves further away from the earth, the gravitational force exerted on it decreases, resulting in a decrease in its weight. Therefore, option B is the correct answer. Question 11 says that a spherical body is moving through fluid, say water. If the temperature of the fluid increases, the terminal velocity of the fluid. So, when the temperature of the fluid increases, the viscosity, which is represented by eta, will decrease as the temperature is inversely proportional to the viscosity. And so, if there is a decrease in viscosity, then the terminal velocity will increase. Therefore, option B is the correct answer. Question 12 says that the width of the depletion region of a junction is reduced under forward bias because we know that in a forward bias the depletion region gets narrow. This occurs because the applied forward bias voltage reduces the potential barrier, allowing majority carrier move toward the junction reduces the width of the depletion region. Therefore, we can say that option C, which is majority carriers on both sides of junction are driven towards it, is correct. In a Young's double slit experiment, if the monochromatic source is replaced by a source of white light, you should keep this in mind that if the monochromatic light source is replaced by white light, we know that white light contains all colors, so the pattern of interference fringes will also change. In this slit, the center part will be bright white, while if we move away from the center, there will be multiple colors in multiple fringes. Therefore, we can say that central fringe is white and other are colored. Option B is correct answer. Moving on to the next question. The question 14 says that in a two input logic gate, both inputs are at 0 and the output is 1. The gate would be, we know that NAND is opposite of AND. Therefore, if we give input as 0 0, we will get output as 1. Same as for NOR and same as for XOR. So we can say that any of the given gates in ABC are true. The next question says that the equation of motion for a body executing simple harmonic motion is given by y is equal to 15 sine 10 phi t plus 5. Then the frequency is given by. We know that the general form of the formula is y is equal to a sine omega t plus phi. Here, A is the amplitude, omega is the angular frequency, T is the time, and phi is the sphere constant. By the given formula, we can say that 10 pi is equal to omega. So, omega is equal to 10 pi. We know that omega is equal to 2 pi f. By solving for frequency, we get f is equal to 10 pi over 2 pi, which is equal to 5. Therefore, option C is the correct answer. The next question says that in a potentiometer of 1 meter length, an unknown EMF voltage source is balanced at 60 centimeter length of potentiometer wire, while a 3-volt battery is balanced at 45 centimeter length. Then the EMF of the unknown voltage source is, the length is equal to 1 meter, which is equal to 100 centimeter. And let the unknown EMF be EMF1. Let this be EMF2 and let it be the length of EMF2, while 60 is the length of EMF1. We know that EMF1 over its length is equal to EMF2 over its length. So by this, we'll solve for EMF1. We get 3 into 100 over 45, which is equal to 6.67 volts. Now we have EMF1. So we know that the length of EMF1 is 60 centimeter. So we will calculate EMF1 by this and we will get 4 volts. Therefore, option D is the correct answer. Question 17 says that 4 molecules have speed of 2 km per second, 3 km per second, 4 km per second, and 5 km per second. The root mean square speed of these molecules in kilometer per second is, we will use a formula which is RMS is equal to V1 square plus V2 square plus V3 square plus V4 square divided by 4. Here V1 square is 4 plus 9 plus 16 plus 25 divided by 4. By solving it, we get under root 54 over 4, and by simplifying it, we get under root 54 by 2. Hence, option C is the correct answer. The atomic number and mass number of a nucleus is Z and A. Their new value after emission of 2 alpha and 2 beta radiations is, we know that when alpha particle emits, it results in decreasing atomic number by 2 and mass number by 4. And when 2 alpha particles emit, they will decrease atomic number by 4 and mass number by 8. And when 1 beta particle emits, it results in increasing mass number by 1. And when 2 beta particles will emit, they will result in increasing mass number by 2. Hence, the final mass number will be Z minus 2 and atomic number will be A minus 8. Therefore, option B is the correct answer. The next question says that the particles which are lighter than protons are called. Photons are particles of light. They have zero rest mass and they are not lighter than the protons. Then we have mesons. Mesons have one quark and one anti-quark. Hence, we can say that they are lighter than the protons. And then we have hadrons. Hadrons are made up of one quark, which includes a baryon and a meson. Therefore, it is not lighter than the proton. Then we have baryons. Baryons are heavy hardons. They have three quarks. Therefore, it is the heaviest one. So, option B is the correct answer. Moving on to the next question. The next question says that each of the 2-point charges are doubled and their distance is halved. Force of interaction becomes n times, where n is, according to Coulomb's law, F is equal to Q1 into Q2 over R square. Here, Q1 is doubled, which is equal to 2Q1, and Q2 is also doubled, which is equal to 2Q2. And the radius is halved, which is R over 2. When we put this into this formula, we will get F is directly proportional to 2Q1 into 2Q2 divided by R by 2 whole square, which will result in 4Q1 Q2 over R square by 4, and which will give us 16 into Q1 Q2 over R square. Therefore, the N is equal to 16, which is option B. Question 21 says that a wire of length 50 cm and cross-sectional area 1 mm square is made of a material of Young's modulus 2 into 10 raised to the power of 10 Newton per meter square. How much work is done in stretching the wire through 1 millimeter? So we know that the length of the wire is 50 cm while its area is 1 millimeter square and its Young modulus is 2 into 10 raised to the power of 10 Newton per meter square, and the extension in the wire is 1 millimeter. We know that work done applied in stretching the wire is stored as potential energy. So we can say that work done in extending the wire is equal to potential energy, which is equal to 1 over 2 into F into del L. We know that the formula of Young modulus is Y is equal to FL over A del L. If we solve it for F, we will have F is equal to AY del L over L. When we will put this in the above formula, this formula will become 1 over 2 into AY over L into del L square. Now we have A here and we have Young modulus, which is this, and then we have the original length, which is this, and at last we have the change in length, which is this. By putting these values in this formula, we can get our answer. So we know that W is equal to 1 over 2 into A is 10 raised to the power of minus 6, while Young modulus is 2 into 10 raised to the power of 10, and then its original length is 50 into 10 raised to the power of minus 2, and its change in wire is 10 raised to the power of minus 3 whole square. By solving this, we get 2 into 10 raised to the power of minus 2, which is option D. Therefore, option D is the correct answer. Question 22 says that a mass M slides from rest down the surface of a frictionless hemispherical bowl of radius r from the highest point A. The velocity of the mass will be, we know that the potential energy of the mass is mgh, which is equal to mgr. At the bottom, all the potential energy is converted into kinetic energy, which is 1 over 2 mv square. So we can say that kinetic energy is equal to the potential energy. We can solve for V, which will be equal to under root 2gr. Therefore, option D is the correct answer. Question 23 says that If R is the range of the projectile, then its kinetic energy be maximum after covering a horizontal distance. We know that the range of the projectile is given by this formula, which is R is equal to velocity squared into sine 2 theta over g. Here theta is the angle and kinetic energy will be maximum, so theta will also be equal to 45 degree. When the theta is equal to the 45 degree, the range is maximum, which is equal to R. Therefore, option B is the correct answer. Question 24 says that which of the following is true for gamma rays? Gamma rays are high energy electromagnetic waves. Talking about their charge, they are neutral and they have no charge. And if we talk about their mass, gamma rays are like photons. They have no mass as well. Therefore, option B is correct, which means the gamma rays are neutral and rest mass is zero. The next question says that the potential difference between points A and points B is the potential difference between A and B would be influenced by how current divides between 3 ohm, 4 ohm, 8 ohm and 6 ohm resistor in parallel and series. However, because A and B are across parallel resistors with zero potential difference, as both A and B are connected through 10 ohm, the potential difference will be zero. Hence, they have the same potential difference, which means we can say that VA is equal to VB. Therefore, option B is the correct answer. The question 26 says that with rise in temperature, the resistance of semiconductor. When the temperature increases, the number of charge carrier, which are electrons or holes, increases due to more thermal energy being available to break bonds and release carriers. As more charge carriers are available, the conductivity of the semiconductor increases and its resistance decreases. Therefore, we can say that B is the correct answer. Question 27 says that when two resistances are connected in series, they have. Here I have two resistors connected in series. When these two resistors are connected in series, they have the same current passing through them. So there is only one path for current to follow through the circuit in a series diagram. Therefore, option C is the correct answer. Question 28 says that a bomb is fired from a cannon with a velocity of 1000 meters per second, making an angle of 30 degrees with the horizontal. The time taken by the bomb to reach the highest point will be. We know that the initial velocity is 1000 meters per second and the angle of projection is 30 degrees. Time taken to reach the highest point can be found using vertical component of the velocity, which is Vy is equal to V sine theta. By putting values and solving it, we get 500 meters per second. To calculate the time, we'll use a formula which is T is equal to Vy over G. Now we know that Vy is 500 and gravity is 9.8, which is approximately equal to 51 seconds. Therefore, option A is the correct answer. Question 29 says that three similar light bulbs are connected to a constant voltage direct current supply as shown in the diagram. Each bulb operates at normal brightness and an ammeter of negligible resistance registers a steady current. The filament of one of the bulb breaks. What happens to the ammeter reading and the brightness of the remaining bulbs? Talking about the current in these three bulbs, the total current will be 3 into current of bulbs. Now if one of the bulb is blown out, now the total current will be IT is equal to 2 into I of bulb. Therefore, we can say that the ammeter reading decreases. Talking about the brightness of bulb is directly proportional to the power it consumes. which depends on voltage. So the voltage remains unchanged, therefore the bulb brightness remains unchanged. So option D is the correct answer. Moving on to the next question. Question 30 says that the path difference between two identical sinusoidal waves is lambda by 6. Their phase difference is, to calculate the phase difference, we have a formula which is del phi is equal to 2 pi over lambda into del x. Here del x is equal to lambda by 6. By solving it, we get pi by 3. Now we will convert this into radians by this 180 degree divided by pi. We will get 60 degrees. Hence, we can say that option B is the correct answer. That's all for this video.